All right, full page example. Consider the following two sets, and here's sets that we've seen before. Numbers that are divisible by 3, so 3, 6, 9, 12, 15, 18, and numbers that are divisible by 5, so 5, 10, 15. In each of the following diagrams, lightly shade the region representing the given set, describe each set in terms of A or B. So this will be like things that are part of A but not part of B, stuff like that. And determine the number of elements in each set. That's where we use the lowercase n to mean number of members. So let's see what they give us here. So first one, they want us to shade set A. That's the multiples of 3. That would be, let's see if I can lightly shade here. Not bad. Okay, so there's set A. It's all the multiples of 3. And when we come to the other questions, they say, what is set A? Oh, never mind, they filled that in for us. They're saying the thing we shaded was just set A. Well, we knew that already. And the number of members in set A would be, this isn't a list of the numbers, it's how many numbers are there. So 1, 2, 3, 4, 5. There are 6 numbers that are in set A. 5 in the main section, and then 1 that also happens to be a member of set B, but that's no strike against it. It's still a member of A. Now, shade set B. There we are. A little sloppy. And, all right, so we shaded B's. That's the multiples of 5s. Multiples of 5. And how many members are there? 1, 2, 3. Easy enough so far. Now, A prime, meaning the members that are not in A. That means you color the entire universal set except you avoid set A. So all that, all that, all that. Just avoid circle A. And they said that's A prime. There are other ways you could describe that by saying it's like the universal set minus A, but this is the simplest by far. Now, how many numbers are not in A? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I think. Oh, wait, 12, 13. Should be 13 numbers that are not in set A. Or the other way to count, we know there's a grand total of 19 numbers in our universal set. It's everything from 1 to 19. 1, 2, 3, 4, 5, 6 of them are in set A. So if you do 19 take away 6, that's another way to get the numbers that are in not A. You take all the numbers there are, subtract the ones that are in A, and what you're left with is the numbers that aren't. Now they have us do the same thing for not B. So now I'm avoiding circle B as best I can. All right. So there's the not B set, everything that's colored blue. We call that B prime, or not B. And how many members are in it? By our shortcut, there are 3 members in B, so 19 numbers minus 3 that are in me means 16 that are not. If you want to check by brute force, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It worked. Okay, now, A intersection B. Remember, when you see that symbol, think of it like an A for and. That means they want the numbers that are in set A and in set B. Well, that's a pretty small group. It's just this. That's the only area that's inside set A and in set B at the same time. So that's A and B, if you write it in English. And the number of members in it, just one. The number 15 is the only number that's in our universal that's divisible by 3 and by 5. And now they do a union B. That's every number that's in the A circle or that's in the B circle. Either one is good enough. So that ends up covering both of those circles and the place where they overlap. You can call that, whoops, too big. You can call that A or B. And how many members are in it? 1, 2, 3, 4, 5, 6, 7, 8. Quick note, if you're doing an OR or a union like this, the A circle contains 1, 2, 3, 4, 5, 6 members, and the B circle contains 3 members. I just want you to notice you can't go, okay, well, we're combining these two sets, so 6 plus 3 equals 9. That's not how many members you get. Why not? Because 15 is a member of both sets. If you're doing this, if you do 6 plus 3, you're counting this guy twice. The only way that you could do this and get it right would be to say, okay, there's 6 members in set A, and there are 3 members in set B, but then you subtract one overlapped member, because otherwise you'll double count this guy and your total will come out wrong. If you make this little correction, and I believe we talk about this later on, then you get 6 in A plus 3 in B minus 1 that got double counted, so I'm making up for that, and now you get a correct total of 8. This is a little premature, but just in case you were wondering why 6 plus 3 doesn't work, this is the catch. You've got to watch for numbers that might get double counted.